All right, this is the Unit 1 test review. So let's see what we got. So number one, which sets shown include elements of set P that are both even numbers and multiples of 4? So what we can do is we can find all the even numbers. So let's find out all the even numbers. Remember, an even number is one that you can divide by 2 and get no remainder. So negative 16 divided by 2 would be negative 8. So negative 16 would work. Negative 12 divided by negative 2, or sorry, negative 12 divided by 2 is 6, so that works. Negative 10 divided by 2, I keep writing the answers. Negative 10 divided by 2 is negative 5. Again, no decimals there, so that works. 2 divided by 2 is 1, that works. 8 divided by 2 is 4, that works. 10 divided by 2 is 10, that works. Or sorry, 10 divided by 2 is 5. 20 divided by 2 is 10, that works. So it turns out they're all actually even. So that didn't really help us too much, but that's okay. So remember, the idea behind an even is that these ones all you can divide by 2. For multiples of 4, so remember, for multiples of 4, the idea is that we can divide them by 4. So let's see what we got. Negative 16 divided by 4 is negative 4. So that's okay. Negative 12 divided by 4 is negative 3. I almost wrote negative 3 again. Negative 10 divided by 4 is negative 2.5. 2 divided by 4 is a half. 8 divided by 4 is 2. 10 divided by 4 is 2.5. 20 divided by 4 is 5. So again, here the idea is we're dividing by 4. I don't like that close bracket. So what we got to do is find out everything that matches in both the purple and the red. We kind of know it's just all the numbers in red just because everything in set P was even. But to double check, negative 16's in both, negative 12's in both, 8 is in both, and 20 is in both. So the answer for both, because we have to say which ones are in both, is going to be the set negative 16, negative 12, 8, and 20. So there we go. That's what we got for number one. All right. For number two, order them from least to greatest. So we have a whole bunch of numbers that we have. It's probably best to find out what they all are as decimals to get some approximations. So what I'm going to do is go into Desmos, so use my calculator. Square roots of 49 over 4. I'm going to double check to make sure that they're both in the square root. They are both in the square root. So this is 3.5. 3.7 is just 3.7, so I don't need to do anything. I didn't need to round. If I do need to round, I probably want to go out to like 3 decimals just to make sure. Radical 22 is up next. We get 4.690. So we'll put that one in next. 4.690. And then the last one we got is 31 over 9. So if we put that one in, 31 divided by 9 is 3.444 repeating. Again, as a decimal approximation, I'm only going to go to 3, just like I did with this one. That way I can kind of see, all right, let me see what I got. So if I look at my decimals, 3.4 is the lowest. This is 4.69, 3.5, 3.7. So 31 ninths is the least. Next up is going to be the 3.5. So radical 49 over, radical 49 over 4, but it's all in the same radical. And then the next one I got is just the 3.7. I didn't have to do anything with that one. That one was just 3.7. And the last one is square root 22. So it turns out that one was the biggest one. And there we go. All right. For number 3, which one will be a rational number? Select all that apply. So again, kind of what I'm just looking for is if any of these radicals actually simplify. If I check out radical 12, over here, type in square root of 12, I can see that my number that I get, this 3.464, that's not rational. I have to write square root 12 with the square root, so I know that this is an irrational number. So a rational plus an irrational is going to become an irrational. So I got to find the ones that are rational. I would not pick this one. Same deal over here, a rational times an irrational. as long as this isn't 0, is going to become irrational. So I'm not going to pick this one either. Square root of 36. Actually, no, square root of 36. Square root of 36 is 6. So that means that this is a rational minus a rational, which must be a rational number. And here again, I've got a rational divided by a rational. As long as this isn't 0 again, and there's no zeros in the denominators, we're going to get an answer that is rational. So I'm going to pick D for that one. Again, you can throw these all in a calculator if you want to throw them all into a calculator, but that's the way that one works. For 4, we got a regular equation to solve. Again, I'm going to take the first step to distribute. Probably going to be the normal first step on most of these if we see the number outside the parentheses. Negative 5 times x is negative 5x. Negative 5 times negative 6 is positive 30. Everything else just drops down. If I see I got the x's are now on the same side. Remember, when they're on the same side, we just kind of do our math normally. So we just combine our like terms. Negative 5 plus 4x is negative 1x plus 30 equals 6. Now I see I got these numbers on opposite sides of the equal sign. So since they're on different sides, we're going to do the opposite to try and get this 1x by itself. So I'm going to minus 30 on both sides. So negative 1x equals negative 24. And the last step we got is we're going to divide by whatever we've got on the x, or multiply if we need to. So we're going to divide both sides by negative 1. So x is equal to 24. So there we go. If I want, I can double check it again, just to make sure. Negative 5, 24 minus 6 plus 4 times 24. We're going to check to see if that actually is equal to 6. So we have to do parentheses first. Negative 5 times 18 plus 4 times 24 equals 6. After parentheses, we'll do the multiplying. So this is multiplying, this is multiplying. So that's 50, and 40 is negative 90. This is like 4 quarters, but then minus a penny each, so that would be 96. So we get 6, and we do get 6 equals 6. So yeah, x equals 24 is the right answer. So that's it with number 4. Nice little regular equation. 5, we've done a ton of these problems already, but the sum of 3 consecutive integers is 132. What are the 3 numbers? Again, if we want x to be the lowest, we can do x, and since these have to be even, we're going to count by 2s. So x plus 2, and then another 2 is x plus 4. So again, whatever number this is 2 more, and then this is 4 more than that. It has to equal 132. So if we combine all the like terms here, we've got 3 x's on the same side, so 3x. We've got the 2 numbers, 2 and 4 will combine. Remember, the 2 doesn't go with the x, even though they're in parentheses. There's no x's with the 2, so I can't add those up. I can't add up just the regular numbers. I can add up 2 and 4. So 3x plus 6 equals 132. That's just going to drop down. We'll do our regular solving. We'll minus 6 both sides. So 3x equals 126. Then we can divide both sides by 3 to get x equals 42. So 42 is even, so that makes sense. All right, that doesn't answer the question because it says what are the 3 numbers. So here we said x was the lowest. So if x is the lowest, that means that the lowest even number is 42. And even means I'm counting by 2s. So 42, 44, 46. So again, you can do it that way. I saw a lot of people on the quiz that we had, when we had a question that was like this, they solved it the fast way. To instead say x is the lowest, say x is in the middle. If x is in the middle, then we have the one before plus x plus the one after is equal to 132. Or as most people saw it, they could simplify to just say x is 3x because these 2's cancel. So on the quiz, a lot of people solve this equation, which is perfectly fine. We divide both sides by 3, and we get x equals 44. But we said 44 was in the middle, so 44 we'll write first, and then the other 2 numbers are going to be 42 right before, even, 46 right after, even, and we get the same answer. So again, you can do this either way that you like. So that's two different ways to do the question. All right. Number 5. Denise buys 3 yards of black ribbon and 5 yards of gold ribbon. The gold ribbon costs $2 more per yard than the black ribbon. She pays a total of $40. What would be the combined cost of 1 yard of black and 1 yard of gold ribbon? So this one seems like a pretty complicated question. So we just want to take it piece by piece. So we know we're buying 3 yards of black and 5 yards of gold. So we want to come up with some good variables. I'm just going to be lazy and say black ribbon is going to be B. Makes sense for black. Gold ribbon, I don't know if I can use my gold. That doesn't look too good. We'll use red for gold, I guess. So our gold ribbon is going to be capital G. The only reason I'm not picking a lowercase letter is my B's kind of look like 6s. I'm hoping that doesn't look too much like an 8. We'll find out. So we know we're getting 3 yards of black and 5 yards of gold. And we're going to pay a total of $40. Now, already this looks a little bit more complicated than some of the stuff we've done in class because we see we have 2 variables. So there has to be something that we can do to get rid of one of the 2 variables. And that's what this sentence here is telling us. The gold ribbon costs $2 more per yard than the black ribbon. So the gold ribbon is $2 more per yard than the black ribbon. And so we might want to think about this with a little table to make sure our equation makes sense. We got the black, we've got the gold. So if the gold ribbon costs $2 more than the black ribbon, I'm just going to put out some options over here. 1, 2, 3, 4, 5. The gold ribbon is $2 more per yard. So this should be 3. 2 plus 2 is 4. 3 plus 2 is 5. 4 plus 2 is 6. 5 plus 2 is 7. All right. Does my equation make sense? 3 equals 2 plus 1. Okay. 4 equals 2 plus 2. Okay. 5 equals 2 plus 3. Okay. So not everybody will be able to go from the equation first. Some people might have to make a little table or think about it before they get to the equation. Depends on where you're at. But with this, what we can do is we can do something very similar to last year. We can make a substitution. We know that gold is 2 plus the black, so this is going to become 3 black plus 5 times 2 plus black equals 40. And now this equation looks normal. So 3b plus 10 equals 5b. Oop, not equals, plus 5b. I gotta be careful too. Equals 40. The b's are now on the same side, so 8b. Oh boy, I got the 8 and the b. Plus 10 equals 40. Minus 10 both sides. 8b equals 30. Divide both sides by 8. So b equals, and this isn't going to come out normal. Well, that's okay, because we got to think about context. If we're dealing with money, if we get something that we get with 2 decimals at the end, that makes sense, because that would be dollars and cents. And 30 divided by 8 would be 3 and 6/8, so 375. So going back to our equation that we had over here, that means that gold is equal to 2 plus 375, or the gold would have to be $5.75. So there we go. Now again, I might get a little bit nervous because I see I got all the decimals there. So let's check it out. So if we're getting 3 yards of black, 3 times 375. We're getting 5 yards of gold, so 5 times 75. We do get $40 at the end. So I double checked my answer. So I feel pretty good about my values for gold and black, but I still have one more thing to do. I got to actually answer the question. What would be the combined cost of 1 yard of black and 1 yard of gold? So I know that 1 gold and 1 black are 375 plus 575. So if I add those up, 375 and 575 is $9.50. So that's a pretty long question. That's a pretty big one. And you can see, I might have tried using guess and check, because I could try with my table over here. I could just try checking, maybe if the black was 3 and the gold was 5, 3 times 3 is 9, 5 times 5 is 25. That's not enough. That wouldn't get me to 40. But when I go to here, 3 times 4 is 12, 5 times 6 is 30. If I add those up, I'm at 42. I'm too much. I've paid too much. So I know the answer had to be between 3 and 4 for black and 5 and 6 for gold, just from my table. So I can use the table to do more than just generate the equation. I can use the table to help me out to solve the problem. But that's number 6. That's kind of a long one. All right, number 7, kind of back to normal. How many solutions are there to the equation? So we're just checking to see if we get no solutions. Number equals a different number. Infinite solutions, number equals number, or one solution, or number equals itself, or one solution, x equals a number. X could equal 0, that's allowed. That doesn't mean no solution, that just means you got 0. So let's check it out. Looks like we're distributing again. So I'm going to take this -6. So -6 times x is minus 6x. -6 times -6 is positive 36. I'm going to take the 9 and multiply the 9. 9 times 2 is 18. 9 times 4 is 36. I'm going to go ahead and combine my like terms. X is on the same side. We do the math normally. 18x plus 36 equals 18x plus 36. And I think I know what the answer is, but that's just a double check. Let's subtract 18x from both sides to get 36 equals 36. Since I got number equals number, number equals number means I'm going to have infinite solutions. And there we go. Remember, the key here is number equals itself is the infinite solutions. That's the case that we got here. Number equals different number. We would have no solutions. And if we have x equals a number, or a variable equals a number, then we'd have one solution. So that's kind of the key on that one. That's what you want to look for at the end. But you do want to solve the equation out to see what you get. All right, for number 8, Ava combines X cups of lemonade at 75 cents per cup with 4 cups of iced tea at 50 cents per cup. She makes a mixture that averages 60 cents per cup. Write an equation to model the situation. All right. So if we look at the lemonade, starting with the lemonade, we're going to have 0.75 per cup times X cups of lemonade. So this is kind of like the homework question we went over with the miles per hour with the people running the marathon. And then we're going to have 4 cups of iced tea at 50 cents per cup. So 50 times 4. And we're going to have some unknown. Oops, let me underline that. 4 cups of iced tea. 50 cents per cup. And then we're going to make a mixture that averages 60 cents per cup. So we know we have average of 60 cents per cup. And here's the key. We know that the cups are X and 4. So overall, we're going to have X plus 4 cups. So at this point, now it's kind of normal. We're going to go ahead and distribute. So 0.75x plus, this is $2, equals 0.6x. 60 times 40 is plus 2.4. All right. So let's see. That makes sense. Let's just double check. That looks good. All right. So let's go ahead, and I like to go ahead and move the smaller amount of x's. Makes sense to me to keep all the numbers positive, but 0.15x plus 2 equals 2.4. We'll subtract 2 both sides. 0.15x equals 0.4. And we'll divide both sides by 0.15. All right, so we're going to get x equals, that one's a little bit tricky, so I'm going to put that one in the calculator. 0.40, 40 or 15? 2.666 repeating. Okay. So that's kind of cool. But if we look at the question, I think I went a little bit too far here. The question just says, write an equation to model the situation. I didn't need to do all this. So the real answer is just this. But I wanted to solve it out. It just looked like it was too much fun. But yeah, that's all we have to do is just write the equation. It says write the equation to model the situation. So that's what we got. So kind of the big key on this one is this x plus 4 idea, that we're adding the x cups of lemonade with the 4 cups of iced tea to make x plus 4 of something new. So there we go. I had a little too much fun, but that's okay. All right, number 9, we got to find the value of x in this equation. So again, I got number outside the parentheses. Probably going to distribute it to both pieces. It might be easier to multiply everything by 7, but I didn't see anybody taking that option on the quiz when we had that on the quiz. So I'm going to do it this way because this is the way that most of you did it. Well, all of you did it. So 1/7 times 3x is 3/7 x. 1/7 minus 2 is 2/7. Now with 7 doesn't come out as a very nice decimal. I don't want to round because if I round, I'm probably going to get the wrong answer. So I do have to leave everything in 7s, which is a little unfortunate. But plus 2x plus 1. All right, well, I was hoping that my 7ths would cancel out, but they don't. So, again, I got to decide. I think I'm going to decide to move my 3/7 x to the other side. Again, I like to keep my x's positive. So 2x, that 2 would be 14/7. So I'm going to have negative 2/7 equals, I guess I'm going to combine 1 and 1/7 also. 8/7 plus 11/7 x. All right, well, again, I would kind of love to just multiply everything by 7 to get rid of the fractions. But again, I didn't see anybody doing that during the quiz. I want this to be a little bit more helpful for you. Personally, I would multiply everything by 7 here. But let's go ahead and do minus 8/7 on both sides next. I'll cancel those out. So negative 2/7 minus 8/7 is negative 10/7 equals 11/7 x. And again, I would probably multiply by the reciprocal. I saw nobody doing that. Everyone was dividing by that number, which, I mean, that's fair. That's what we practiced on in class. So I can divide everything by 11/7. If I divide by 11/7, I'm going to get negative 10/11 for x. So there we go. So that's going to be my value for x. And we're all set. If I want to double check, again, I can double check the answer. Again, so this is kind of weird. I am going to double check it just in case. So we got 1/7, 3x minus 2, or no, x, 3 times 11/10 negative. All right, so that's 0.7571, so on and so forth. On the other side, 1/7 plus 2x plus 1. So 1/7 plus 2 times negative 11 x plus 1. Well, that's not the same. That's a little bit suspicious. So that means we might have messed something up. Oh, I didn't type it in right. So that would be an issue. I got negative 10/11. But that's okay. We got to do some error analysis. It's kind of normal. Not super convinced, but we'll see if it works out. Hey, look at that. We got the same wacky decimal. That looks pretty good. Negative 6.675324, 675,325. Okay, well, that looks pretty solid. That looks pretty nice. And that is actually a rational number. We can see it's repeating, right? 6, 7, 5, 3, 2, 4. 6, 7, 5, 3, 2. And then this would be a 4, but we had to round it up. Negative 52/77 on both sides. All right, very cool. That's what we get for number 9. All right, 10. This is a nice little literal equation. We have to solve for b. Since it tells us we're solving for b, I'm going to circle the b. I know I'm done when the b is totally by itself. So I see the ax is on the wrong side. I got to move the ax. I'm going to minus ax on both sides. So y minus ax equals negative b. I'm going to circle the b because it's not by itself yet. I still see it still has the negative sign. So I have to divide everything by -1. So negative y plus ax equals b. And then I'm done. B is now by itself. So I know I'm done with the question. And that's it. We're just using our properties of algebra. For 11, we are solving for the object's mass m. This is another literal equation. To give myself a little bit more space, I'm going to go ahead and rewrite this down here. V squared equals 2gm over r. This time I'm trying to find m. So if I circle m, I can see it's not by itself. We could do this in one go, but I'm going to multiply both sides by r to cancel out the division. M is not by itself, so I can see I'm going to need to divide. And the things that are with the m are 2g. So I'm going to divide both sides by 2g. rv squared over 2g equals m. M is now by itself. Got that a little bit too close to my squared right there. Since the m is by itself, I know the question is done. So there we go. Nice little easy one where we're just undoing our operations. All right, looks like we got another one of them. That's okay, works for me. Write the formula in terms of the height h. Again, I'm going to write it down here to give myself a little bit more space. This time I'm solving for h, so I'm going to circle the h. I can see I'm dividing by 3, so kind of like the last one, I'm going to multiply both sides by 3. So that'll cancel out the 1/3. So 3v equals pi r squared h. I see again, h is not by itself yet. I have to divide both sides by pi r squared. And I get 3v over pi r squared equals h. H is now by itself. I'm already done. That's it. Those ones are fast. On part B, we actually have some numbers to plug in. So it says find the height with the volume is 147 pi centimeters cubed. Radius is 7. So what we're going to do is plug these in to the expression that we got up here. So it's going to be 3 times 147 pi over pi times 7 squared. Well, I know the pi's are going to cancel out, so that's good. 147, well, all right, I think the answer is going to be 9 because I think I know what 147 is. But let's go ahead and put it in the calculator just to double check. 3 times 147 divided by 7 squared, and it is 9. Perfect. The reason I knew that that was going to be 9, and this is centimeters here, is because 147 is 49 times 3. 7 squared is 49. So in my head, I canceled out the 49s and just did 3 times 3. So I actually did less work than the calculator by thinking about it. But that's what we got. So we got 9 centimeters. The reason we know it's centimeters is we can use our science skills. So in this equation, we got 3v over pi r squared. Well, v is centimeters to the 3rd power. R is the radius, that's centimeters, but we're squaring it. And if you remember the properties of exponents from last year, this is going to be to the 3rd power divided by to the 2nd power. When you're dividing the exponents, when you're dividing with the same base, then you subtract the exponents. 3 minus 2 is 1, so this is going to be centimeters to the 1st power, or just centimeters. That's how I knew that the units were going to be centimeters on that one. All right, 13, we got a nice little inequality. So back to some of our kind of not having to think too much. We just kind of go ahead and do it. 3, distribute that to both pieces. 8, distribute that to both pieces. So 3x plus 3 plus 5x is less than 8x minus 1. X's are on the same side. We do regular math. So 3 plus 5 is 8. 8x plus 3 is less than 8x minus 1. Minus 8x both sides, because we always want to get the x's on the left side when we do the inequalities for ease. 3 is less than -1. Well, okay, they did make us think, so we do have to think about this one, because all the x's went away. So we have to ask ourselves, is 3 actually less than -1? It's not. This is false. So the answer to this one is that there is no solution. It just tells us to solve, so we can solve it. We can give an answer of false. We can give an answer of no solution. If you wanted to graph it, it didn't make us graph it, but remember the graph for this one is the one where we just leave it blank. So if you were to actually put anything on that number line, then you would get it wrong. So it's just a blank number line because there are no answers. 3 is never less than -1. All right, well, that's it with 13. 14, graph the solution of the inequality on the number line. So, okay, seems very similar to the last one. In fact, it looks like it's almost exactly the same as the last one. We're going to distribute again. -2 times 3 is -6. Negative times -x is plus x. Greater than or equal to 5x plus 4. I have x's on the same side, so I'm going to combine those to become 2x minus 6, greater than or equal to 5x plus 4. I'm going to go ahead and move my x's to the left. Now, again, you could have chosen to move the 2x if you wanted to. It is nice to have the x's positive, but since I have to graph, again, just seeing the answer at the end with the x on the left, to me, makes the graphing a little bit easier. So this is -3x minus 6 is greater than 4. I'm kind of out of space. I'm going to have to rewrite that up here. I can then add my 6 to both sides. It's pretty good. So -3x is greater than or equal to 10. And then I can divide both sides by -3. I get x, and then I got to watch out because this was negative. Remember, this sign is going to flip. So 10 thirds negative. All right, so I got my inequality. X is less than or equal to -10 thirds. So I know where that is. 9 thirds would be -3. 12 thirds would be at -4. So I'm going to be right here. I'm going to do a solid dot because I remember that these ones are the solid dots. These ones are the open dots. And again, whenever I have the x on the left, I can just kind of follow the arrow like some people said in class. So I can go ahead and just have my arrow go this way. And then I would be done. That's it. I'm all set. If I want to double check though, you can always pick a test point if you try 0, just as something to like double check. We would say that 0 is less than or equal to -10 over 3 is false. 0 is not less than a negative number. So we would have our arrow would point away from 0. And again, that's what we have is our arrow is pointing away from 0. We're not going towards 0. We're going away from 0. So that's number 14. Again, not too crazy. 15, we have the compound inequality. Remember, the word or does not mean that you do one or the other. It means you do both. And the answer is probably going to be 2 different graphs on the same number line. So I have to do both parts of the question. Luckily, they look a little bit small. So I'm going to do the red one first. I'm going to add 15 to both sides. So 5x is less than 20. I'm going to divide both sides by 5 to get x is less than 4. Okay, that seems kind of normal. That was actually kind of quick. I'm going to do the blue one next. I'm going to do -23 on both sides. So 4x is greater than or equal to, let's see, 7 minus 23 is going to be negative 16. Divide both sides by 4. X is greater than or equal to negative 4. Okay, not too bad. You can see in this one, since this was a positive 4x, I did not flip the side. Even though 16 is negative, remember it's whatever you're dividing by. So there we go. We drop down the word or. And that's it. That's all we have to do. So it's very easy. We just have to remember that or does not mean you only do one part. Or does mean you do both. And or just is always going to stay as an or. So there we go. All set. All right, for 16, it says write a compound inequality for the graph below. So the trick here is we can see that in this line, there are no arrows. So we know it has to be an and inequality. So if I go from my first endpoint, I know x is going to be greater than or equal to negative 4. And if I go for my second endpoint, x is going to be less than or equal to negative 1. And I'm all set. That's it. That's all we got to do. Our other option, because there is another way you could choose to do this, is you could say, well, instead of doing all this, since it is an and, since it is the bar like this, I could also do the triangle. So if I want to do the triangle inequality, I can just put down my two endpoints, negative 4, negative 1, put x in the middle. I can see these are both solid dots. So x is going to be greater than or equal to negative 4, and negative 1 is going to be greater than or equal to x. And I could also have it like that if I would prefer. Both answers are correct, so whichever one you want. Both of them are and inequalities. It's really up to you. We did a little bit more practice with the first one, but the triangle inequality is a little bit easier to write. All right, for 17, we can see we're given ourselves, now they give us a triangle inequality here. The area of the rectangle is described with the inequality 96 is less than or equal to a, which is less than or equal to 420. Part A says write the compound inequality for x. So the trick here is to remember what A is. A is the area. So the area is the base times the height. So in this case, it's going to be 1.5, not 15, 1.5 times 4x, but 1.5 times 4 is 6x. So what we're going to do is take this 6x and plug it in for A. So 96 is less than or equal to 6x, which is less than or equal to 420. Part B says solve the compound inequality for x. So I'm going to rewrite it down here. And remember, in the triangle inequality, we just work on all three sides. So we want to get the middle side to be x. So we're going to divide everything by 6. 96 divided by 6, that'd be 1016. 420 divided by 6, 42 divided by 6 is 7 with the 0. And that one's done. So even though that one looks a little bit tricky because it's got the little geometry part to it, actually that was actually pretty fast. As long as we know what to do, as long as we know how to replace the A, this was actually super quick. So that was kind of nice. All right. Next up, we got 18. So we have the absolute value equation. So remember, for these absolute values, what we're going to do is rewrite it as two of them. The first one we just write just normal. Just take away the absolute value bars. The second one, what we're going to do is take our 8, we're going to switch it to negative, and we're going to have 5 minus x. So we have to solve each of these. These looks like they're pretty quick to do. Minus 5 both sides. So we get 3 equals negative x. Divide by negative 1. Negative 3 equals x. 5 minus negative 3 would be 5 plus 3 for 8. So I'm happy with that. And then this one, minus 5 both sides. So negative 13 equals negative x. Divide both sides by negative 1. 13 equals x. 5 minus 13 is negative 8. Take away the negative, we get 8. So I'm happy with that as well. Looks pretty good. So that's what we got for number 18. So the trick there is to split it up into the 2. So remember, the deal is just take everything away and leave it normal. And we do have that one negative sign we can add to the other one. All right, 19. Isabel is buying 6 angelfish. She wants her total cost to be no more than $2 above or below $36. Write an inequality to model the cost x in dollars of an angelfish. All right, so this one's going to require a little bit of thought. So we know we want it to be no more than $2 above or below 36. So that means that whatever our total is, we want that to be no more than $2 above or below 36. So that tells me that from 36, we should be less than or equal to 2. So we want no more than 2. All right, well, we somehow need to get that 36 into play. So we want the total minus 36 should be no more than 2 or negative 2 because we want to be within 2. So I think that's the setup for this one. That looks pretty good. I think that's what we want. Let me just say the 36 is going to be the 36 here. The 2 is the 2. The total is the total. But we also know what she's buying. So the total is also 6 angelfish. So we can actually replace the total with 6x. Oh, wait, this only takes care of one of them. This only takes care of it if it's larger than 36. So we want above or below 36. So I think we actually need to do above or below. We can just do the absolute values. Other option, if you don't want to use the absolute values, we could set up an OR inequality. We could do total minus 36 is greater than, this should be in orange. This is our option if you don't want to do the absolute value. You can swap the absolute value out with solving this one still. Total minus 36 is greater than or equal to negative 2. So we would have to solve both of those. Yeah, I don't know. I'm thinking this one, just doing it with the absolute value would be a little bit easier. And then since this is a less than, I don't know if this is an or either. This is going to have to be an and. Because it's a less than or equal to. This is a tough one if we want to do it without the absolute value bars. I think we just stick with the absolute value bars. Let's see where we get from there. Anyway, I still need my absolute value bars. Oh, yeah, okay. Because then when we solve it, now when we split it up, that makes a lot of sense because we have to split it up and we're going to get this anyway. So it turns out either one's going to be about the same distance. All right, so this is just like the other one. First, we're going to do it without the absolute value bars. And the second one, we take away the absolute value bars. And we're effectively, remember, we're doing a negative. So if we're going to multiply that side by negative, that means we're going to have to flip the sign. So yeah, it turns out we do have the exact same equation. So we could have just done it that way. We could have done it without the absolute value bars if we wanted. Well, either way, we're going to add 36 to both sides. So 6x is less than or equal to 38. We're going to divide both sides by 6. X is less than or equal to, well, this isn't going to be normal. 38 divided by 6. 6.33 repeating. Interesting. Over here, I can add 36. 6x is less than or equal to 34. Divide both sides by 6. X is greater than or equal to, so 34 divided by 6. 5.6 repeating. All right, well, that's what we got. $5.66 and cents. So let's see. I need a number that's bigger than that. So if I'm thinking about this in terms of dollars and cents, it have to be $5.67. 5.66 cents would be not enough. In terms of dollars and cents, 633 repeating is too much. We have to go down to 633. So that would be what we'd get if we'd solve it. Interesting. But I think I see something. I think I had too much fun again. I think this question is just asking for write an inequality to model the cost x of dollars of an angelfish. So it turns out that was kind of it. We just had to do that part. That's okay. If I wanted to do it the other way, they do say to use x. I do have to use x in dollars. So if I wanted to do it with the and, I could do 6x minus 36 is less than or equal to -2, and 6x minus 36 is less than or equal to 2. So that would be my other option, would be to write the compound inequality that way. So that's like going and doing one extra step, which I guess I could have just circled this part here and the blue and the red. So yeah, well, that's all right. I mean, it's still fun to do these problems. I like the end, because the end we actually had to think, because the answer that we got with the math doesn't make any sense in the real world. You can't have 0.66 repeating for the cost of an angelfish. It has to be in dollars and cents. So very interesting. Very interesting. But anyway, yeah, you just had to go one step. You did not need to go out and do the whole problem. But you can if you want. That's the beauty of this. All right, well, anyway, last one. So graph the solution of the absolute value inequality on the number line. 5 is less than 2, absolute value, x plus 4, and then a plus 3. So again, the key here is we have to get the absolute value by itself. So get the absolute value by itself first. So that means I have to subtract the 3 first. I really don't have much of a choice. So we're going to do minus 3 both sides to get 2 is greater than 2 times the absolute value of x plus 4. I have to then divide everything by the 2 that's out front. I can't distribute. That's not what I'm doing. I have to get the absolute value by itself first. So I'm not allowed to distribute first. So that's going to become 1 is less than, oops, I changed my color there actually. Make that green. So 1 is greater than absolute value of x plus 4. And now I can split it up. So again, the first way I split it up is I just take away the absolute value. 1 is greater than x plus 4. The other way that I split it up is I take away the absolute value and I make the other side negative. But if I make the other side negative, I flip the sign. 1 is less than x plus 4. All right, well, I'm not too happy because I see the x isn't on the side that I like, but that's okay. I'll still work with it. Well, minus 4 both sides. Alternatively, I could do a whole bunch of steps to get the x by itself, but I think I'm just going to have to deal with what I got. -3 is greater than x. So I know my point's at -3. Greater than x. So I got to think, is -3 greater than 0 true? No. So I need to go away from 0. That's that way. All right, the red one we got, -3 again. -3 again. That's -4, sorry. So -5 is less than x. So I get -5 is less than x. So -5 is less than 0. Well, that's true. So I have to go from -5, and I'm going to go towards x. Since that's true, I go 2x, or sorry, 0. So if I went 0, going this way. But I can see that these two things are actually going to collide with each other. So I don't want the arrow to go all that way. I actually want to go this way, that way. And so that's my answer. Or if I want, I can just have the 2 circles and I can just color in the bar, kind of like we saw in that other question where we just had that one bar that we had to represent. All right. So that makes sense. That makes sense. All right. So that's everything we got for this one. So we can see There are a couple tricky ones, but there's also a lot of them that are very, very similar to things that we did in class, and we've been doing a really good job at practicing some of the equation solving. We've been doing a really good job of following the steps, a really good job of seeing when to distribute, good job of seeing when to combine like terms if the things are on the same side, to do the opposite if you want to move things over to the other side of an equation. And we did a really good job when we were doing the graphing part with all of the inequalities too. So this will be kind of a big one, but I think we're in pretty good shape for it. So that's all we got.